crabs?
They have fiddle.
Duh.
Yeah.
No, it's
Paper.
They have one arm that's one claw that's quite a bit bigger and is shaped sort of like a fiddle.
Only
Sort of.
Sure.
Sort of.
But that's like, the old, supposedly mermaid tales are from drunk sailors who thought manatees looked good to them, and I'm like, yikes! How drunk do you have to be before a manatee looks like a good thing?
Really?
Manatee. It's from VeggieTales.
Can we watch it?
All right, so here's another one that I stole from AP Central. Pardon?
I was confused. I thought we were doing the quiz.
No, we're going to do the notes first. So, fiddler crabs eat by sifting through sand to find food particles and then scooping them into their mouths.
Yum.
Yeah. Wildlife biology studied a random sample of one species of fiddler crabs to estimate the speed at which they feed, measured in scoops per 30 seconds.
Why do you know that?
I want someone to measure how fast I can eat in scoops per minute.
For-
Slices per minute of pizza.
For the 40 crabs in the sample, the mean was 67.65 scoops per 30 seconds,
Whoa.
and the standard deviation was 6.61 scoops per 30 seconds. Create a 90% confidence interval for the mean feeding rate of all fiddler crabs of this species. Does the interval support the conclusion that the average feeding rate for this species is more than 2 scoops per second? All right, so anytime you have one of these, before you jump in and start doing things, you should test to see if the assumptions and conditions have been met. So, what sort of assumptions do we need to have here?
Is it random?
All right, well,
It's not a proportion, so we don't use success failure.
indeed not. So notice it says that it's a random sample. This is a random sample. And I usually go ahead and glom into that of 40 crabs. Which is, what am I going to talk about here?
Less than 10% of all fiddler crabs.
I bet.
Indeed, less than 10% of all fiddler crabs of this species.
Isn't that a species itself?
I thought so too, but apparently not.
What's
So,
above species?
Kingdom, final class, orphan.
Genus.
Genus.
So lots of things.
yeah.
Debonair, King, Henry, drink chocolate milk or something.
That's the metric system.
No, it's not.
I
No, it's
think
not. It's
The,
on
the,
board.
the, the drink chocolate milk is the
No,
metric.
it's Debonair, King, Henry, domain, kingdom, phylum,
No, it's
class,
kingdom, phylum.
order. I don't really care about that. It's Gavin Geisler, dating Marion Man.
That's. I do not know who that is.
So great.
I know who Marion is.
If you ever want to know anything about Northland, you could just watch our class videos and just tiny pieces of gossip about what's happening outside the window.
Yeah.
Yeah. All right, what other things do we need here?
Austin and Saturn out there.
That was good.
You need to say that they're independent. Just kidding.
Oh.
Normal.
So, how do we check to see if this is nearly normal?
I don't know. You say that it's 30 samples.
It
or
appears
30,
to
right?
be unimodal and symmetric, without strong skewness or potential outliers. To check this, we will make a histogram.
We don't have data.
But we don't have data.
We don't have the data, but since there are 40, that's enough to where we can assume that this will be nearly normal.
It's more than 30.
More than 30,
That's what I
exactly.
said.
Since the sample is larger than 30, we can assume
Sorry, I just have snot in my throat.
that the sampling distribution of the means is nearly normal. Yeah, I should, in this class at least, I should always have my notes out.
Yeah.
Seems like wisdom.
Wow.
Words of
Words of wisdom.
Anyone get that word of the day?
I did.
I got it in 3.
I got it in 3.
Y'all are very impressive. I got it in like 5. But hey, I got it.
Did you do the word today, Mr. Davis?
Yes, sort of. I helped some of my
Other kids do it?
ninth graders.
We got
Well,
this down
I don't know
here.
where my notes are, so I'll proceed without. They're around here somewhere in one of the mini stacks of paper. So, are we missing anything for the assumptions and conditions?
I don't think so.
So, what all are we supposed to look for? What's on our list?
Randomness.
So, you can turn back a page or two and see what's on the list.
Independence. I said that.
Independence
So-
Day.
So, what do we need to know about independence?
That. Oh, because the 10% is independence, right?
Yeah, the 10% helps us know that we have the independence. Okay,
We're done.
all right. So, like I said, I would suggest not spending all your time doing the formula. Partly because if you were to write something wrong on that, well, you lose points. So instead, tell them what we're going to do. Well, we're going to do a one sample t interval for population means. I think that if you just put a one sample t interval, that would be enough, but the full name is a one sample t interval for population means. So we'll grab our calculators and go, okay. So stat test one sample t interval. Number 8. We're doing this from statistics, right? And we know that the mean was 67.65. And the standard deviation was 6.61. That there are 40 fiddler crabs. And we're supposed to be doing a 90% confidence interval. By the way, before I hit calculate, a 90% confidence interval, is that interval going to be wider or narrower than a 95% confidence interval?
Wider.
Got to vote for wider
Wait,
and a
hold
vote
on,
for
let me think about this.
I think it'll be narrower because
Narrower.
it's more
Narrower.
it targets in and therefore there's more outside of it that
I don't know yet.
Narrow.
could fall.
I'll say narrow.
I just need you to stop talking for like 2 seconds so I can think about it, please. No, I think
Think about it this way.
95 is they're more sure that it's in there, so it's wider.
But we're going down to 90.
I'm saying 95 is wider.
So 90 0.
So a 95 is wider. And the way I remember it, honestly, is if you want to have 100% confidence, you have every number in the world in there. Right? I'm 100% confident.
It's between the negative and
Infinity.
I don't even remember what I answered.
You said wider.
Did I?
Yeah.
I said narrow.
So you don't have to write all the stuff that you have in there. You just need to give the confidence interval. Some of you are writing more than you need to
so
on
you just have
this.
to say what the test is called and then the answer.
Yeah.
No, that's nice.
Now, on the tests, you should give things that you didn't have before. So like on this one, we already knew that the mean was 67.65, the standard deviation was 6.61, and that n was 40. We knew all those things. A lot of times on the test, they'll tell you something else. For example, they'll tell you the t-value if you're doing a t-test. Okay?
Or like if you do the other ones, it tells you ZMP.
Yeah, you're going to have to give the p-value so you know whether or not to reject the null. So our interval, is from 65.889 to 69.411. Does this interval support the conclusion that the average rate or average feeding rate for this species is more than 2 scoops per second? You're like,
Yes.
because this is scoops per
30 seconds.
scoops per 30 seconds.
So it's like just over 2 scoops.
2.19.
So we would need to divide that by 30. And you should show something like this. Scoops per second. Which is all greater than 2. Okay, good with that? All right, let's go on to, I think there's one more example, yes? All right. This is another one that I stole from AP Central. Once I found that they had all these videos, I was like, they have some good examples. And I try to give you examples that aren't in your book because it's like you're going to read those anyway. Well, some of you read them. But that gives you more different things to look at. So an article on the internet claims that the average vertical jump for teens is 15 inches. A group of statistics students at a large high school selects a random sample of 20 students from their school. Pardon?
It was about vertical jumps, you can keep going.
And measured their vertical jumps. The students in the sample jumped an average of 15.8 inches with a standard deviation of 2.33 inches. Do the data provide convincing statistical evidence that the average vertical jump at this high school differs from 15 inches? Well, their average is certainly over 15, right?
Yeah.
But
15 feels like a lot of inches.
yeah,
Like to just.
yeah, I never had a 15-inch vertical. Might have had a 5 at one point, but
We had to do the vertical test in off season 3 years ago, but it was so bad. And Coach Rob was like, "Really, you're that tall and you can't jump that high?" I was like, "Yes, Coach Rob."
It doesn't
So-
change
I
it.
know,
Like,
that's
your
what I
height
was
does
like,
not
I'm
make
like,
you
it
jump
doesn't
any
mean anything.
higher.
He was like, "You're so
It
tall,
means
that's
you
all
can
you
reach
can jump."
something
I'm
that's
like,
higher, but
I didn't come here. I have to take this class. I didn't choose to.
I don't have to take your sass, though.
I did. And then when I finally was able to bench press 50 pounds, he sent a video to my mom, which is so out of pocket. Anyways.
All right. So, when we're looking at this, it says, does it provide convincing statistical evidence? Some days I can say it, some days I can't. Convincing statistical evidence, that means we need to do a test. So, what's h sub naught going to be for this?
That it's the same as 15 inches.
The mean is 50.
All right. So that mu is equal to 15. And on this one, what is our alternative?
It doesn't
Not
equal to
equal to
15.
15.
Yeah, and you have to be careful about that. Again, that's when you're putting it into your calculator, it's important that you know that it's not equal to. By the way, your hypothesis is always an equality. Some of you tried to do some very interesting things on yesterday's quiz with that. The hypothesis is always an equality. The alternative is always the inequality.
Yeah.
Okay? Where mu is the mean what?
Vertical jump.
Or high school
Height.
teens.
Now, we should think about the population from which this is drawn. What population is this drawn from?
Just
Large
one
high
school.
school.
Yeah. All right. So, do we think we can apply this to other high schools? Maybe, maybe not.
Not here.
I think we can assume
I don't know.
Me neither.
I would say, I tend to be more conservative. I would say it's the mean vertical jump for all students at this high school. One of the easy mistakes to make on this is to say it's the mean vertical jump for the students in this sample, or to say something that makes you think it's from this sample. But we know the mean vertical jump from this sample,
Indeed.
right? Now, for this one, we've only got 20 students.
Uh-oh. We need to make
Oh,
a
you don't?
histogram.
We're going to have to make a histogram eventually. So let's talk about, and let's go ahead. I always try to do it now. Let's set our alpha level. It didn't give us one, so we'll use 0.05. Oh, that's not a,
That's sigma.
man, I was just going through all the Greek letters.
U.
Mu, sigma, alpha, delta. All right. So what sort of things do we need to have here?
Random sample.
All right, so this is a random sample
Less than 10%.
of 20 students, which is, I would say, at the very least likely less than 10% of the population of a large high school.
Random people.
So this takes care of our independence, right? What it doesn't take care, our randomness and our independence are taken care of here. What's not taken care of?
Normal.
Is it nearly normal?
Yes.
Okay.
It is.
Unfortunately, we can't just say that it's nearly normal. So we'll go to Stat, Edit. We'll put in the data. My very first one, I messed it up. I was doing a data set today from chapter 24 and it had like 60 entries in it.
Oh, wow.
I was sure glad I had StatCrunch.
I just think even if I got it, I would know how to use it. So.
I think I missed one.
I use Stat Feb in my data for my project.
For your what project?
That project, the
Oh, there's two
What's
13.75s.
normal?
Is this what you got?
That's what I got.
mine's a water problem.
All right. Well, in the interest of time, I'm going to look at one of yours. And that's a very sort of normalish looking. So if this is on the AP exam, yes, you do draw what this looks like.
I can do it. How good does it have to be?
Not great.
Here we go, like this.
Yeah.
Sick.
Too bad.
You remember when Emma Beck said you should draw her own graph paper? Mr. Davis?
I'm sorry?
Do you remember when Emma Beck said
Yes.
that she used to draw her own graph paper?
Miss Emma.
I think that's so funny. Like,
So-
it totally would have been less effort to just buy graph paper.
Yeah. The really bad dad joke at this point is, if your graph makes a rude gesture, then it's good.
That's a good joke.
Huh.
That was a knee slapper, huh? All right.
Hilarious.
So a histogram of the data.
No outline.
Exactly.
What if it does?
If I had $1 for every time I've typed that,
Do it.
shows no outliers or strong skew.
So even if it doesn't look normal, if it doesn't have outliers,
Look, it doesn't have ulcers.
outliers or is not strongly skewed, you can use it.
Yes, it doesn't have to look normal.
Like the one we did yesterday didn't look normal.
Right. So the one nice thing about this is we don't have to put all this data in because it gave us all the stuff. So we'll go ahead and
Wabbit.
we can do stat test. This is a t-test.
So that's
Data.
data.
We're going to do it from data,
Data.
Beta male.
15.8.
Ha ha hardy
Oh, so our muse of naught is 15. Oh, I want to do it from stats. What the heck?
Not equal to. I want to calculate.
I don't even know what that means.
It means to the contrary, my friend.
That makes sense. Oh, so we're doing it from stats now?
Yeah.
Yes.
This is statistics.
You can go ahead and do it from the list, but they gave you the stats.
I see.
Oh, I did the data.
We'll see how much the answer differs.
Hopefully it won't.
Yeah. Hopefully.
My T is 1.534.
Mine is 2.
Yep.
I did 5.
So
But then it starts to differ.
a one sample
This is 535.
Yeah. It's a little different.
t-test gives us that t is equal to 1.535 and p, and I don't know why they use a lowercase p.
0.141466893. Why do the answers differ a little bit?
Because somewhere this was rounded off. So on yours, did it give you the mean when you did it from the data?
Yes.
Yes.
15.8. Well, you have to. No, never mind.
Yeah, it gives you the mean is 50.8 and it gives you standard deviation 2.3319858.
So yeah, the standard deviation had more decimal places in it. So what do we notice about p?
It's greater than 0.05. We don't reject L null.
So we do not. So we fail to reject the null.
Failed to be rejected.
Reject L null.
Dude, that's the only outcome you have in life.
Failing to reject.
Failed to be rejected.
then you probably won't have really like let yourself be vulnerable at any point.
There you
Oh
go.
wow. Okay.
Squid.
Squid. All right. So there is no, or there is insufficient, we'll say it that way,
All right.
statistical evidence
It caught her by surprise.
to conclude
Until the S just kind of looks like it's on
I
its
should
own line.
yeah,
It's like,
my writing on this gets worse the closer it gets to the bottom,
She's so funny.
Girlfriends now.
Been for him.
that the mean vertical jump for students at this school
Is not 15.
yeah, or differs from 15, either way you want to say it.
So the mean is exactly 15.
We don't have any evidence to
No,
say
Oh,
that.
So-
because you're not accepting.
right. The mean for this sample is bigger than that, but because of the size of the sample and because of how little it differed from the mean that we think, we don't agree. By the way, occasionally we'll have one like this and you'll get that the mean of the sample is like 14.6. And at that point, I don't know. I'm going to have to ask Mr. Hedstrom about this one. I'm like, why bother doing the test? I mean, there's no way it's going to show that you should go the complete opposite direction. At best, it can say, there's no difference. All right, that is it. Let me give you back your quizzes.